Welcome back. Let's talk about how to get this decryption homework done. So what I'd like you to do is write a program that decrypts a BMP image, a bitmap. I'm going to post an encrypted BMP file, and then I want you to decrypt it and send me the original, BMP file. So in order to do that, what I've given you is a fully functional program that's an encryption program. And it's a reversible process. So you need to study how this thing works, study all the steps that it takes, and then reverse all of those steps. So you'll end up with a program that just does the same thing but backwards. So essentially you'll end up with a decryption program. Then the only thing you need to do is figure out what the key is, right? You'll have the algorithm, so you need to figure out what the key is. And for the key, I'd like you to use a brute force key guessing approach. So just try every possible value of the key and see which one works. The key is an 8-bit value, so there's going to be 255 possibilities. So just run the decryption algorithm in a loop with, counting to 255 for all possible keys, and then you'll generate 255 files basically. And they'll all be BMP files, but they'll all have a BMP extension, but only one of them will be a valid BMP file. And you should be able to tell which one is valid just by looking at it in Windows Explorer. Okay, that's the basic idea. So let's see here. I want you to use the brute force approach. So I want you to just guess the keys. First, you need to write a program to generate the inverse encryption part of it, and that involves reversing these function tables, which we'll look at. And then you'll try all 255 keys. Tell me which key you're using, and then that key breaks out into 4 numbers basically. It could be 0, 1, 0, 3, or it could be any pattern of numbers. And I want you to just tell me what that pattern is. So that's easier than it sounds once we get into it. All right, so you're going to have this source code CPP file, and you're going to have this epic encrypted picture BMP are going to be posted. Let's take a look at the source code and see how that works. So I've got this plain picture file right here, and I've got the source code right here, which I've got open in well, there. So I've got this. You need to take the plain picture BMP file, this little donut. Well, this is the input file, which you're not going to have. You're only going to have the output file. But let me run this encryption program. Right now, it's an encryption program. So let me run it. So F5 thing runs, and it just terminates right away. But what it does is it generates this epic right here. Okay, so it took ppic, which is a human. Visually, a human can see this interpretable BMP file, and then here's this epic BMP. This is an encrypted file, so Windows can't actually display this, so it puts this little icon on there. But now what you need to do is take this epic file and turn it back into the donut. Now, I'm going to change it. It's not going to be a donut, all right? But you're going to have an encrypted file, and I want you to turn it back into a plain, decrypted, visually, something you can actually tell that what it is visually. All right. So what we're doing is we're taking this encryption algorithm here, which we went over in detail in the notes or in the previous video. This is a MiniDes program. So let's look at this and kind of compare it to the source code just a little bit. So there's 4 stages: 1, 2, 3, 4. There it is. And what you're doing for each byte in the file, so it's reading every byte in the file one by one and then encrypting it to some other byte coming out the end, right? So there's a byte coming in at the top and then one coming out at the bottom. So for each stage, you take this W, and first you do a substitution on it. That's this step. Then you do this transposition on it, which is just swapping the bytes. Then you do this XORing with the key. And that's the end of the first stage. And then that'll happen 3 more times. Okay? So in more detail, like it'll read each byte of the file right there, and it'll use that byte, because a byte has a value between 0 and 255, so it'll use this as an index into a table along with this value, S, and it'll produce an output byte. Okay? And so the W0 is just the input byte that's coming in, and S is part of the key. S is the first 2 bits of the key, the leftmost bits of the key. Likewise down here, R is the next 2 bits of the key. It's the well, there's 2 bits here, and then there's another 2 bits, then another, then another. Okay, that's R. And then Q is the next 2 bits, and then P is the next 2 bits. Okay, now the transposition is just swapping the low order byte with the high order byte. So it's low order byte concatenated onto the high order byte. It just reverses the order of the bytes. And then XOR is just literally an XOR operation with the key. So let's look for that in the code. So I got all this code right here. I have these transposition tables that take a byte, so it's a value between 0 and 255, and then it takes that either S, R, Q, or P. So there's 4 values of a piece of the key there, basically. And so these are just discretely defined lookup tables. They're functions that, just given a byte value between 0 and 255, it'll return another byte value between 0 and 255. These are just 4 random tables that all take a character as input and then another number which is derived from the key. Okay, so here we go. Let's just kind of go through this encryption. This encryption process here that I'm highlighting, that's basically this thing right here in the notes. So W is passed in there, and the key is passed in there. So W comes right in here, and then the key comes in here, and then the key is busted up into P, Q, R, and S. That's these over here. That's the S, R, Q, P. Okay, so P is busted up for you into these. Then the first stage over here is this chunk of code right here. So we're taking W0 right here, and we're putting that into this table along with S, and we're getting a byte out. That's what's happening on this line right here. We're doing a substitution of W, byte W, for another byte based on a piece of the key. Okay, that's the substitution that's done. Then you call swap bytes, and that just does this thing right here. It just swaps the low order nibble for the high and the high order nibble. Just reverses the first 4 bytes and the last 4 bytes. Then here's the XOR operation. Okay, that's this thing right here on the flow chart. So these 3 lines here are this, and then that happens 3 more times. Okay, which is this stuff right here. That's basically it. So it takes a byte in and the key, and it returns a byte. It returns Z3. Okay? So this is called in a loop for every byte in the file, and that's what happens in main. Okay, main is, let's go through main. So main, I'm opening up a plain picture, so a human readable bitmap file, the donut. I'm opening up the donut, and I'm going to write that to an encrypted file called epic. And in here, I'm just reading every byte in the file. Right here in a loop, I'm reading every byte in the file, and I'm just, I'm calling encrypt. So I read a byte C, and in this case, the key is 42, which I'm going to change, by the way. All right, 42 is just the key. So I'm calling my encrypt function that we just went through and getting an encrypted byte back, and then I write that out to the file. That's it. So if I run this, which I did a little while ago, I ran it on epic here, this epic donut thing, and it produced this encrypted file, which you can't see. So I want you to reverse this. Okay, so basically you're gonna reverse what's happening here. You're gonna open the epic and then write it to ppic, and then you need to invert this. You need to take this encrypt function right here and turn it into decrypt, and that just involves two things. It involves reversing the order of operations. So instead of going down this way, right, you want to come up this way, right? So over here, I'm going this way. You need to go that way. That's the first thing you need to do. The second thing you need to do is invert these tables, right? There's these tables are called 4 times based on the PQRS values, which come from the key. You need to invert these tables. So I've hard-coded these tables in here. Here they are. And you need to invert them. So let's kind of look at these a little bit and give you a little heads up on how that might work. So this is the first table in C, in hard-coded string, hard-coded literal. That's what I put in the instructions, right? That's what I'm talking about when I say a C constant literal array initializer syntax. I'm just talking about this right here. Okay, so in set notation, which we've been studying, it looks like this. It's a set of ordered pairs, right? So in other words, if you put in a 0, you'll get a 1. If you put in a 1, you'll get an 18. If you put in a 255, you'll get a 117. So what does that look like down here? It looks like this. If you go to location 0, you'll get a 1. If you go to location 1, you'll get an 18. That's these first 2 pairs. And then this last pair, it says if you go to location 255, which is way over here, you'll get a 117. So I've broken it out into 32 bits times 8 rows. Okay, to get, this will be the 255th bit here, or bit index 255. Okay, you need to reverse this. You need to create a table that has these reversed. Now it's a little trickier than it sounds. So it's simple, but it's easy to get confused. So what I've done is I've given you what it should look like in set notation here. Let me move this up here so we can compare it a little bit. So what do we got? So in set notation, generating the inverse just means flipping the ordered pairs around, right? So 0, 1 would become 1, 0. So that would be this guy right here. And 118 would become 18, 1. So 1, 0 is in this second location. 18 would be somewhere in here. So you have to flip the pairs and then put them in the right order. That is if you were doing it in set notation. You'd have to order them by the first element, 0, 1. That's if you were doing it in set notation. But we're doing it in this here. So in this, constant literal 2-dimensional array thing. So what is that going to look like? Well, it's in here. Let's see. If you go to location 1, you should get a 0. So so there's going to be a 0 here. Okay, there's going to be a 0 at this location. That's what this pair right here means. 1, 0 means if you go to location 1, you should read a 0. And if you go to location 0, you should read a 30. So there should be a 30 here. That's the inverse of what you see over here, right? Here, if you go to location 30, there's a 0. So when you go to location 0, there should be a 30. Right? Likewise, let's see, if you go to location 255, the inverse of Well, it's a little confusing, but this is the answer, or this is 3 numbers of the answer. And once you get it working, you'll be able to see. Look, it's this way. Look, what you got to do is count through an index from 1 to 255. Then what you do is you'll go to this table that's right here, and you'll read a 1. So that means you need to go to index 1 in the new table and write a 0. Okay, then you'll count on your iterator, you'll count up to 1. You'll read this value, which means you need to go to location 18 and write a 1. Okay, then you count one more time. You read a 121, which means you need to go to location 121 in the new table and write a 2. It's like that. And if you do it right, it'll look like this when you print it out and make it look like set notation. Okay? So it's pretty straightforward. It's writing a loop with one line where you're doing an assignment. And once you figure out what that line needs to be, it's pretty simple. But I don't want to give you any more hints than that, because I want you to think about it. But I've given you what the answer should look like, at least partially. And if you get it working right, you'll be able to see that it's working. Okay? So I'd like you to do that programmatically. So I gave you a little template down in here called fill fi. But basically, I want you to first write some, like I've allocated fill fi somewhere, haven't I? Where is it? Yeah, here it is. This stuff, I just want you to fill that. Right now it's an empty array, but write a function that fills up these guys, and then print out these tables. Okay, you need to do that kind of first. Is generate the inverses of these tables and put it in fi, or f inverse is what it is, and dump that to the screen, and put it in your submission. Okay, then you figure out if you needed to reverse this or not. Maybe you do, maybe you don't. But you do need to reverse all of this. You need to get this guy running backwards. What about these? You think you need to do anything to that? I'll let you think about that. I don't want to give you the answer. Maybe you do, maybe you don't. You do have to reverse the order of these guys. Those have to go backwards. And you have to generate the inverse tables up in here. Okay, what about down in main? Well, right now I'm just doing one file using a key 42. Okay, I'm going to change the key, and then I want you to do this 255 times. All right, so generate a key from 0 to 255 and run this thing here and generate 255 files. And I've given you a little bit of code here that you could, from this, you should be able to construct dynamically a file name that has a number in it. You want epic 1, epic 2, epic 3, all the way to epic 255. Or I guess from 0 to 255. Generate 255 files, and then just look at them. Like, look at them, and one of them will be an actual picture, and the rest will just look like this. Okay? That's it. It's a lot of fun, I think. And I'm going to make it into a little contest. The first 5 of you will get some notoriety and a virtual prize. Okay, I think that's it. I don't think there's anything else to talk about. Make sure you watch the previous videos where I kind of go through this a little bit more. Okay, have fun with that. I'll see you next time. Bye.